Okay, so in this video, we are going to talk about the concept you'll definitely use in real life, the amortization formula. So whether you're taking out a car loan, student loan, or mortgage, this formula helps to determine the fixed payment you needed to pay off the loan over time. Okay, so this is the concept of this formula. So if you borrow a lump sum today and agree to pay it off in equal payments over time with interest, the loan is said to be amortized. To calculate the size of those regular payments, we use this formula over here. So in this formula, R represents the regular payment. So this is what you need to pay over time. And A represents the loan amount or the present value of the annuity. And here I represents the interest rate per period. To get the interest rate per period, what you have to do is you have to divide R by K. So R gives you the annual interest rate in decimal and K gives you the number of compounding periods per year. And N represents the total number of payment periods. To get that value, you have to take the product of K and T. So K gives you K gives you the number of periods per year. It is the compounding periods per year. And T is the total number of years that you have to do this annuity. So this formula tells you exactly how much you'll pay each month to fully repay the loan, including the interest by the end of the long term. So it's used in mortgages, car loans, student loans, and business loans. Okay, so now let's try an example. So take few minutes to read this problem. You can pause this video and read this problem. Let's try this. So this is the application of amortization formula to a real home buying scenario. So a couple wants to buy a house priced at $230,000 and they have $50,000 saved for a down payment. So the total amount they have to borrow is it's going to be $23,000 minus 50,000 because they already have 50,000. So they have to borrow $180,000. So, and also they are looking at 25-year mortgage with interest rate of 9 per year. The annual interest rate is 9 and this is compounded monthly. So here what you have to do is you have to find out the monthly payment and also you have to calculate how much they have to pay in total and how much that the interest, you have to calculate the total interest value as well. So to calculate this, you have to use the amortization formula, which is over here. So now to use that formula, you have to calculate A, I, and N. Okay, so here in this formula, A is going to be $180,000. So this is where this calculation happens. And I is the interest rate per the period. So to get that, you have to divide R by K. R is the annual interest rate, which is 9%. And K is 12 because this is compounded monthly. So this value is going to be 0.0075 per month. And then we need N as well, the total number of periods, which is K times T. K is 12 and T is 25. So if you multiply 12 by 25, you'll get 300. So now you can plug this value into your formula and you get R as $180,000 multiplied by 0.0075, 1 minus 1 plus 0.0075 to the power negative 300, and you have to simplify this value. So if you simplify this value, you'll get this is approximately equals to 1500 and $10.553. So the requirement payment would be this value. So this is the payment you have to do each month for 25 years. Okay, moving on, the second part. So in the second part, you have to find the total amount that they will pay before they own their house. Okay, so the total amount that they must pay before owning the house is the down payment plus the total of the 300 payments. So for the second part, it's going to be the down payment plus the payments that they have done over 300 period of time. It's this. So if you use your calculator to calculate this, it's going to be $503,168. So this much of money that they need to invest to own this house. And last part, see, you have to calculate how much interest will they pay. So the total interest is the total amount paid minus the total paid for the house. So the total interest is going to be 503,168 minus the house is around 238 sorry $238,000. So if you subtract this value, you'll get 273,168. So in summary, the couple pays monthly payment of this month for 25 years, and over 25 years they will pay a total of this much, and this much will be the interest.